Good evening all friends. Now this is the question of chapter 3 3.2. This is actually 3.2's question number 16 and this is question number 17. The answer of this question you will get just in one step. If you know for this equation you are proving something in terms of a cube. So it's a question of about 2 pages. This is a question of about 1 page. I am giving you the direct equation just in 1 or 2 steps. So your answer of this equation can be obtained by using Cayley-Hamilton theorem and characteristics equation. How? I am showing to you. A cube minus s1a square plus s2a minus s3i equals to O. Here what is s1? S1 means sum of principal diagonal values. Sum of principal diagonal values. So what do you mean by S1 friends? S1 means summation of these 3 principal diagonal values. What do you mean by S2 friends? S2 means sum of minors of principal diagonal matrix. So what do you mean by sum of minors of principal diagonal matrix? Find a minor of 1, find minor of 2, find minor of 3 and then add all the minors. That will be your S2. So what will be the minor of 1? Hide this first row and first column. So minor of 1 will be 6, minor of 2 will be 3 minus 4, so minus 1 and minor of So the minor of 2 will be 3 minus 4, so minus 1 and lastly minor of 3. Hide third row, third column. Your minor will be 2. So sum of minors of diagonal matrix will be 6 plus 2 minus 1. So it will be 7. And friends, what is S3? S3 means determinant A. So whatever you are seeing in a matrix form, just make it into a determinant form. So what will be the determinant of this equation friends? It will be 1 into 6 plus 2 into minus 4. So determinant A will be minus 2. Put all these values into the result number 1. So what will be your final answer? So your final answer will be a cube. What is S1 friends? 6. What is S2? 7. And what is determinant A? Means S3, that is minus 2. Put it of S3. The answer of S3 is minus 2. So the total answer is minus of minus 2. So plus 2. So your final answer will be A cube minus 6a square plus 7a plus 2i equal to O. Right? This is the question of 2 page. If you will find the value of a cube, you have to multiply matrix a square and a, put all the values into the result, and then you will get 0, 0, 0, 0, 0, 0, 0, 0, 0 as an answer. Why? In this shortcut, if you are able to find out 3 values S1, S2, S3 by Cayley-Hamilton's theorem, right? Then your answer of this question just in one step. Right? So this shortcut will give you the answer in 1 to 2 steps. Meanwhile, original method will give you the answer in 2 pages. Right? Then you can also apply Cayley-Hamilton's theorem in 2 cross 2 matrix also, and you are able to find out this equation just in 1 or 2 steps. But in 2 cross 2 matrix, Cayley-Hamilton's theorem will be applicable somehow differently. How friends? Here your Cayley-Hamilton's theorem will be in principal diagonal value, just subtract A. Whatever the determinant value you are getting, just expand it by multiplication of principal diagonal minus multiplication of secondary diagonal. So what you are getting by expansion? A minus 3 into a plus 2 plus 8 equal to 0. Friends, keep in mind, wherever you are seeing a constant term only, you have to replace constant term by constant into I, and then you will get final answer in terms of matrix, friends. So whenever you are seeing a scalar term or constant term, replace it by scalar into I value. Now simplify this equation. You will get your final answer. A square plus 2a minus 3a. So minus a minus 6 plus 8. Right, friends? Here just replace this constant term by constant into I. So this is your final answer. See, in question number 17 of 3.2 of your book, question is given like this: a square equal to ka minus 2i. So your k will be directly 1 by this Cayley-Hamilton's theorem. So if you want this answer just in 1 or 2 steps, you can apply Cayley-Hamilton's theorem irrespective of your original method. So it is very much useful in 2 cross 2 and 3 cross 3 matrices, and you will get the answer just in 1 or 2 steps if you know this shortcut. If you like these shortcuts, then please subscribe us on our channel, right? And please share it with others also. Thank you, friends.